Hello, guys. Welcome back to the third installment of the
Tapes.
TAPES podcast. I'm your host, Jaden Calderon, with your other host,
Anthony Santos.
and we will be discussing what unit today, Anthony?
We will be discussing the third unit of APES called population. Now,
Okay.
population accounts for 10 to 15% of the total exam weight.
And now, Anthony, tell me what that means.
It means that at least 10 to 15% of the questions will be about this topic.
Yes, like how I have a 10 to 15% body fat percentage.
Oh, do you?
Yes. But
Mhm.
anywho, so tell me more about this lesson.
So, as it's in the name, we will be talking about populations with different species,
Yes,
humans, mammals.
humans, and we will be learning like the different like ways they decide to reproduce, right?
Mm-hmm.
And they're yeah,
Mm-hmm.
yes, well,
So,
yes,
well, yes.
well, yes,
Yes.
yes. Okay,
Okay,
so
it's usually
let's
never that
continue.
awkward. Jada?
So the first topic we will be discussing is generalist and specialist species. Well, I will elaborate more on that. Generalist
Okay, then.
species are a species able to thrive in a wide variety of environmental conditions and that can make it and that can make use of a variety of different resources.
Mm-hmm.
So take
Can
raccoons, for
okay.
example.
Mm-hmm.
They are a generalist species. They live in wide variety of environments like forests, mountains, cities, rural, and suburban areas.
Okay.
And they're also omnivores, which means they eat anything from fruits, nuts, to even meats. So like human trash.
So Jaden, what's a specialist species then?
A specialist species is a species that uses a relatively small portion, in extreme cases, only one, of the available resource types. So pandas, for example, are specialist species since they live in southwestern
China.
in the Tibetan Plateau.
So
And 99% of their diet consists of branches, stems, and leaves of bamboo. They consume 35 to 80 pounds of food per day. Okay, so Anthony, what is the first topic that we'll be discussing in this unit?
There's actually a second topic in this unit, and it's about case-selected and R-selected species. Now, case-selected species, they are basically organisms that are larger, have fewer offspring, mature after many years, have longer lifespans, reproduce multiple times in their lifetime, and live in stable conditions. Now, an example of a case-selected species would be the giant panda.
As we discussed before.
Huh?
As we discussed before.
Pandas only give birth to one or two offspring, but usually only one of the cubs survives. Cubs, panda cubs may still live with their mothers for up to 3 years and will not reach sexual maturity until 4 to 8 years old. And a female panda may only reproduce 5 to 8 cubs in her lifetime.
So, Anthony, like after the accident I had and like I hit my head really hard and like I got amnesia, can you tell me, I have a question. Are humans R selected or case selected?
Humans are actually case selected.
Oh, and why is this?
Because they have like a reproductive span of like 9 months.
Yes.
Like from when they first become impregnated to when they give birth to
Yes.
a child, it's 9 months. And R selected species, R standing for rapid, tend to be smaller, have many offspring, mature early, have short lifespans, may only reproduce once in their lifetime, and thrive in disturbed environments. An example of an R selected species would be mosquitoes. Adult mosquitoes.
Moquitos?
Adult mosquitoes mate within the first few days after emerging. After mating, they live for only 3 to 5 days, and female mosquitoes can lay up to 100 eggs at a time. And these eggs are hardy. Well, the eggs can overhardy and can overwinter. To wrap up that topic, most invasive species, which we've talked about before, like the zebra mussels,
Yes.
tend to be R-selected species because they have a high reproductive potential, grow and mature, which basically means like reach their sexual maturity quickly, and produce many offspring, which is why invasive species are able to colonize and negatively affect the environment they're introduced in. Invasive species also outcompete specialists and case-selected species.
Mm-hmm. Now, can I give a more current example of invasive species?
Mm-hmm.
So remember when all those lanternflies were annoying people?
Mm-hmm.
I have a horror story actually with that.
So tell us, Jada.
So one time I was standing where was that? I think I was on White Plains
Mm-hmm.
near the train station, and I was there. I was standing. I was talking to Treasure on the phone, my friend, and out of nowhere, like I look down on my shirt, and tell me why there's a lanternfly landed on my shirt. I'm like,
Wow.
girl, why do you feel so comfortable? See, that's
Mm-hmm.
another thing. Why did they feel so comfortable with where they were?
Because invasive species, they don't really like they don't have any natural like predators in the habitat that they're introduced to.
Oh, so that why they're so friendly
Just
with
like
me? I don't know why they're chopping it up with me. Like I wasn't gonna just smack him off my shirt.
our next topic is about survivorship curves.
I
Do
will
you care to
discuss
tell
that
me
one.
more about survivorship curves?
Well, survival curves displays the relative survival rates of a group of individuals of the same age in a population. Survivorship curves differ for K and R selected species. Type
So,
1. Oh,
wait, Jaden.
yeah.
So, I've heard that there are three different types of survivorship curves. Can you?
Yes. Type 1 is late loss. Large numbers of their population survived from birth to death.
Okay.
Correct? And large percent of the population survives because they provide care for their young and thus increase the chances of survival for youth to old age.
Mm-hmm. So, what's the second type, Jaden?
Well, Anthony Santos, type 2 is a constant loss. Death birth is constant,
Mm-hmm.
right?
And what about the last one?
Well, this one is early loss. A large number of their population dies early in life. This is because a small percentage of the population survives because they provide no parental care and thus increases high infant mortality rates.
Okay. So Jaden, in this topic about survivorship curves, we also have something known as carrying capacity. Can you tell us what that is?
So, carrying capacity is the maximum numbers of organisms that an environment can support without degradation of resources.
Mm-hmm. Jaden, what so I've heard that if a population overshoots, like if they reproduce too much and don't have enough biotic potential, they can possibly have a what's known as a dieback. Can you tell us what that is?
A population that grows very quickly and exceeds its environment's carrying capacity can overshoot the maximum number of organisms that their environment can support. It is followed by a dieback.
Okay.
Population growth and resource availability is another topic that will be discussed that follows the growth charts.
Mhm.
So, can you tell me more about this?
So population growth and resource availability are basically factors that can limit growth, which in turn limit the carrying capacity an organism and like a species of an organism can like. Ooh, I'm gonna cut
Now,
that anyways.
Anthony, can the amount of species in that population affect it? Like the resource availability and population growth?
Yes, we actually have density dependent and density independent resistance, which are factors that limit growth. A density dependent resistances include competition of resources, predation, parasitism, and disease. And density independent resistances include natural disasters and droughts.
Hmm.
Actually, in these population growths, we have two types of graph. We have what's called exponential growth, which is basically a hypothetical where an organism has unlimited resources and they never reach a carrying capacity and are thus able to grow. Oh, thus are able to grow their population like
Very fast,
very fast and like almost
like the
infinitely.
lantern flies.
And then we also have what's known as logistical growth, where an organism reaches a carrying capacity because it doesn't have enough resources to maintain us like it has enough resources to only maintain a steady population. Now,
Tell me more
talking
about
about
this.
exponential growth, I've actually read about an experiment recently. This guy named John B. Calhoun, however the f you say that name, he experimented with rats, and basically these rats were supplied with like everything they needed. Like they had an infinite amount of food, and they had an infinite amount of water. Like they had everything that they needed, and as a result, since they had everything that they ever wanted, the rats simply got bored. They had such a big population boom, and they were like they were living in paradise basically. And they just decided to kill themselves. Like
Oh,
yeah, they just like since they had everything that they wanted, they got bored. Like they basically kill themselves because they got bored. And one last thing we need to keep in
Discuss.
check is what's called as fecundity, which is basically the ability fecundity, which is the ability to like it's a vocab word meaning to produce offspring. Now, Jaden, huh?
Never heard of that
Me neither. Now, Jaden, we also have another topic about age
one.
structure diagrams. Can you tell me more about this?
Well, they are basically pyramids
Mm-hmm.
that show population and the age of the population,
Mm-hmm.
right?
So, if it's a diagram, it must have an x and a y axis, Jaden.
Yes.
So, can
So
you tell
the
me more about this?
x-axis is the number of individuals, male or female.
Mm-hmm.
The y-axis tends to be the center of the diagram, and it's the age groups.
Mm-hmm.
So like pre-reproductive, reproductive, post-reproductive, and then for pre, that would be the ages like 0 to 14.
Mm-hmm.
'Cause
Like
they don't got no
adolescence.
period or sperm. And then
I'm 26. Stand up.
reproductive would be 15 to 45 because they're hitting that sexual maturity age.
Mm-hmm.
Then post,
Post
that's when
reproductive.
they're going like through menopause. They're losing that drive
They're
to
losing the ability to
reproduce.
give birth. Yes.
Yes.
Now you need to remember these numbers because they will be on the exam. What?
Yes, you need to remember these because it will be on the exam.
Speaking of age structure diagram, you will more likely than not see one of three. What we have known as a growing population is more of like a triangle, like it's more triangular in shape, if you get the gist. And then a stable population, it's like more of a square, but like towards like the post reproductive stages, towards the post reproductive stages, they have like it starts to shrink. Like it's almost like it's almost like a tower. Like
Upside down Eiffel Tower.
you know like the what's it called? The Empire State Building, like it's like it has a
Yes.
triangle at the top and then it's
Yes.
like a box.
Yes, bro.
Basically that. Lastly, in a declining population, pre reproductive stages, there's more of a population in like reproductive and post reproductive stages, but in early like pre reproductive stages, there's not enough like of a population,
Yeah.
which is why it's declining.
Yeah.
Growing populations occur because younger age group make up the largest amount of a population size
Yes.
because younger people and women are in the workforce. Stable populations occur because all reproductive ages seem to have a similar percentage of population growth, almost box-like in design, like I said before, because nations are well off and women delay having children to pursue an education and workforce. Yay, feminism. And a declining population occur because a large percentage of population is close to the reproductive stages. They delay having children because the nation is economically and socially developed.
Hmm.
Now, something else which is very important to this topic is the total fertility rate, which is also known as TFR. Tell me, Jaden, what is TFR?
Well, TFR, like Anthony said, is the average number of children a woman has during her reproductive years, ages 15 to 49. And TFR is TFR is affected by a lot of societal and economic factors that Anthony had discussed prior to
Mm-hmm.
this. Developing nations tend to have a TFR of greater than 2.1.
Greater than or equal to 2.1. Mm-hmm.
Hmm. And then developed nations tend to have a TFR of less than or equal to
Mm-hmm.
um, 2.1.
Which is also known as a replacement level fertility.
Sí, señor.
Can you tell me like factors that like can you tell me more about the societal and economical factors that go into TFR?
Well, there's age of the first pregnancy, education. As women become more educated and stuff, they feel as though it is not that necessary to have
Mm-hmm.
children, and they realize that in this economy, it is not okay to have children.
It's true.
And then family planning again with the in less developed countries,
Mm-hmm.
um, they can't really decide if they want to have children. They kind of need to,
Mm-hmm.
like more so for like work related
Mm-hmm.
things. But in more developed countries, they're able to plan out when they could have children.
Mm-hmm.
There's healthcare, a lot of abortions nowadays, and then there's birth and death rates.
Okay. So, Jaden, the last thing we'll be learning about in this unit is what is known as human population dynamics. Can you tell me more about that?
So humans also experience a carrying capacity limited by density independent factors and density dependent factors.
So, what are these density independent and density dependent factors, Jaden?
Well, density independent factors could be storms, fires, heat waves, and droughts. Density dependent could be disease transmission, territory size, food availability, and access to clean water and water.
So, in this, in this,
Why did I say water twice? But I mean, water and air, people. Water and air.
So, in this topic, what's very important to learn about is the rule
Rule
of
of
70.
70.
You remember that, Jaden, right?
Yes.
Can you tell us how awful that FN was?
It was horrible.
So, the rule of 70, which is the doubling time of population, it basically means the amount of time for a population to double in size at a constant growth rate.
Basically, you do
What's the calculation,
70%
Mhm.
divided by the growth rate, which will give you the doubling time. R must be a percentage. Don't forget about that, y'all.
R is basically growth rate. So it's basically 70 divided by the growth rate, which must be a percentage.
So, is that it? That's all of it.
That's
Yes.
it. Yay! So, Jaden, do you have any
So I feel as though in this unit
like
it was pretty simple, but again with the calculations.
Mhm.
How do you get a
There is a lot of
percent?
calculations in this unit.
How do you get percent? No idea. So you're gonna really have to figure that one out. But you can ask our lovely, beautiful teacher, Miss Antalan, who will give me 100 points for saying that.
Will she?
Yes, you will. Um.
So,
So
how did we feel about this unit?
how'd you feel about?
I shared what I thought.
Oh yeah, but
think
I
it was
liked
okay.
it.
I
I
think
liked
it was very
it.
fun.
It was cute. I got a little confused with the growth population charts, but you know what? You'll live.
You live.
You'll live. You'll get it.
You live and learn.
I might have gotten it like wrong 1,000 times on that Ed puzzle, but she kept returning it to me, and I kept getting it wrong. But you know what? It's fine.
It's fine, yeah.
So I think that's it for this
For this
episode.
installment of
Tapes. I'm Jaden Calderon,
and I'm Anthony Santos.
and you were watching.
This is you want to get copyrighted, and this is Tapes.
Boom.
Oh,
Oh.
oh. Cut your mic. Cut your mic.
Cut your mic.
Cut your mic.
Anyways.